So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 220 and in this video we continue with our exercise, and in our last video we stopped at the point where I tried to explain step 70, which is our end position pointer, and we put all the code in a while loop, and this while loop is our sort algorithm more or less. Not all, but the biggest part. And this condition here is our break condition. So I check the loop end position pointer with the head of linked list param. Let me show you what I'm doing here. So the loop end position pointer is this pointer. I check if this pointer is at this position here. So if it's pointing here, and then I know this here will be not going in. So, and then I talked about a little bit how we do this. So you can see in this end position if statement, first of all, the loop end position pointer must be the same at the swap pointer second position. So first, this both must be the same. After this both are the same, then I will set this here. And after I set this here, you can see that was the step here 16. Here I set this here at this point, then it goes out, and anyhow it will start here again. And when it starts, it checks now loop end position pointer, which is here now. I say it should not equal, this is a not equal sign, to the first position pointer, and you can see head of linked list. Oh, sorry, we are comparing here this one, so it should not be the same as the head of linked list param. So it should be not this both should be not the same, and if they are both the same, the loop is finished, which means this array, this linked list should be sorted at this point. All right, that was 17, and let's go here to 18. Let's see what do I have here on 18. 18, yes, this is a very special case. So here you can see I added again a if. And this if is special because you can see this if I added only because we can see here this green scribbles. You can see this green underlined scribbles here. And when I hover my mouse over it, the IDE is complaining. This green scribbles means most time it is warning you have to do it, but you can ignore it if you go the risk. If you are sure made sure that there is no problem. In my case, I won't show you the problem. So first of all, when I hover my mouse over it, there is the number C6011. This is a code which you can watch on the web, and it says here differencing null pointer, and in this case it means it is possible. So the possibility is there. Anyhow, when I click on this one, it is possible that this one could be a null pointer, and differencing means because here I try to access this null pointer, and this one would cause a problem. That's why this is not allowed, this access here. What I try to do is only allowed with pointers who have a node, for example. Let me show you here. So for example, if this pointer here, this end position, for example, swap pointer first position here, let's make it this. The first position has here a node, so accessing the score data of this node is possible. But let's say the first one here was never set. Let's see, the first one was here. And we know the pointer must be not set. So when it's the case when this is never set, for example, here is my swap pointer first position where I assign it. But what happens if this one already failed? So for example, this one failed. That means this one will be never set. That means this one will be all time a null pointer, for example. Just so in case, and that's why there is a strange warning. And I want to show you this warning here on the web. You can see it is this warning C6011, and Microsoft says you can read it. Indices that your code differencing a potentially null pointer, and potentially means it is possible, right? They say not it is a null pointer, it is potentially, because there is a way that it can be a null pointer, and to avoid this, they showed here a code what you can use, and they say you can just make a if check to avoid this. With other words, here is a code with the problem, and here they just surrounded it with a if. Here it is, just surrounded with a if, and that's it. And exactly the same thing I did here too. So you can see to get rid of the scribbles here, I surround it just with a if, and this is the this other if here. What you see, it is just here to avoid this pointer. So, and this time I show you surrounding with the code surrounding with. Let's see where this is first. Which one I have to surround with? Yes, this is the second one. This one. So this one now I show you how you can use the snippet again. Again, learn the shortcut, but I don't know it. That's why I right click and I go here to the snippet section, surround with, and in this case I choose a if. Not careful, not the sharp if. The sharp if is we will learn later. This is on top. You can define something. We need just a normal if, and here is the normal if. You can click on it and you can see so it is surrounded. The important is when you surround it, you have to set, of course, this condition. And in my case, the condition is here, this one here. Yes. And this condition is also very interesting and important that you set this one, because what I'm doing here is I say only if this here, the variable here, which can be potential a null pointer, must be true. You can see this is a AND. I use here a AND. That's very important. This must be true and this must be true. So both must be true. Then you can enter this block here. If this is one of them is not true, you can't enter here. And so I get rid of this scribble, but I have another problem here, I think. And first of all, let's add this one here, and I'll show you the next problem with that one. What was that? Where is that? Ah, here. It was step 80. Okay, let's go here to step 90. I hope it's on step 90. Oh, let's see. Step 90. Yes, it is in step 90. And the next problem is, you can see I wrote here a strange comment that is just for myself. Warning for differencing null pointer. That was this warning. That's why you have to check it with this, which is our if check. That is what I just explained to you. And here I wrote something strange. I said you check for exception. And what I mean here for exception is, here my if statement checks if the swap pointer first position is false or this one is false. So both must be true, right? We know and this and here, or by the way, you can use another and as well an alternative way. You can write here and that will work too. But like I said, in programming, they use most time this one here in general. This and means both must be true. And then, only then, it will enter this block here. But I said in one of my other videos, when you see a if statement, you have to consider the other case too. This is the true case. What is if it's not true? And this one is our step 90. Step 90 means here, it is not true. So with other words, step 90. Okay, we step 90 means here. Let's go here on top. Again here. If it's not true, that's why I have here a else. And interesting is I use here a throw. What was this throw? Do you remember what throw was? That was a keyword. And do you remember what a throw makes and how we use that? That's very important here. That's not easy, I think. I even don't know if I used it right. 90, let's see, here is 90. Okay, there's a hint how we use this. But do you know how we use this throw? And that's a little bit not easy. I talked a lot about exceptions, but why I use a throw in a if and how I use this. Okay, let's say so. It is an exception, of course. That's why I use this word throw. And throw need what? Do you remember it? It needs a try catch block. But where is the try catch block here? I have never defined a try catch block here, right? I have just say, okay, if this if statement is not true, I throw here, and what is this for 7,7 here? 7,7 here is just an integer, it's just a number which I have to react. But like I said, where is my try catch block? And important, if you remember, the try catch block is something you want to make for example, for the whole, also this throw will only react if you have a try catch block. This throw itself here will react to nothing. So with other words, if I would create no try catch block and execute now this code, and if let's say one of them is false, it will not enter this block, it will enter this else block, and it will throw 7,7 and it makes nothing. And the reason we talked about it in exceptions a little bit, that throw needs a try catch block. And the question is where I create this try catch block. We are on 90. So let's go here in main, and you can see in my main I have a try catch, not in this main, sorry. Here in this main I have a try catch block. I called it 19. This looks a little bit big, but let's make it first here, the first 19. So I create a try catch block in my main. And interesting is when I scroll down here to my main, I have to create this try catch block after I created the list here. Very important, because if you have not created a list, it's probably a null pointer, because we need a list, right? And here I have already something like that, but I can if you want, you can use again the trick with the surrounding with a try catch block, or you can write it with your hand. I use now the trick, I think, to show you this again. I select, this is the call, this is the sort linked list call. So this is the call. And in this call here, in this function here anywhere it's a throw, and this throw will react to my try catch block. So, and to make this true, you just can write it with your hand try and then do all things, but I'm a little bit lazy. So what I do is just mark this again, right click snippet, and you can see normally you should learn here perhaps the shortcut, because you need many times this kinds of stuff. And then there is also a try catch block anywhere here when I see it. And here is a try, and I click on it, and you can see it is created for you here. And very important is, this is how you create a try catch block. You have first a try block and a catch block, and they use all time the right thing here, which I'm not using right now. This is the normal thing what you should use, this const std exception reference, and then accordingly here one more thing. But I'm not using this because we have talked about exception a little bit, not too much, and we have not talked about this library exception. Normally you should use this library std exception, but in our case we are still learning. It's not too wrong not to use it right now, but if you want to make it right, you have to learn this library and then try to understand how you use this library and delegate from this one. But right now, I'm not using this one. It's very good that you realized we need a try catch block for this throw, because now this throw here can react to this one. And now we have to set up this try catch block, by the way. So let me show what I did here. I wrote here just 17. Let's write me here step 17. And perhaps I should write also a comment here. Catch at the case if, and now we have to scroll up and see what's the problem here. So one of this pointer is 0. All right, none is a null PTR. Okay, that was here. Catch the case if swap. Yeah, if oh, perhaps I should really copy this one here because I don't know the names. If this one, let's copy it. Just I catch which one? I catch this one. I just copy this one here, and I paste this one here. The whole thing as a comment is false. So catch this one here. Catch the case if this one is false, and this one is good. And then you can see this one will be called, and we have here a problem. Oh, not a problem. You can see I talked a lot about the throw, and there are different ways how you can use it. Also, this throw, I use here an integer. The question is, what was this integer here? Actually, this integer is a random number which I put in. You can put here any number which you like. Important is that this number will be catched in your try catch block. So here is my try, here is my catch, and we learned also we can have here different kind of catches, right? If you remember this try catch block, I can make here more catches and so on, but I use here not this exception like I said. Instead, I use my own error code, and let me see how I did this here. Okay, I called it here error code. You can see this is just a variable actually. So you can see here catch int error code, and then we will react to this one. This is not all time the right way, but like I said, you should normally use this const exception library, std library. That's why it is made. But to understand this at the beginning, it's good that we make this one. So I call it error code. And the reason why I call it error code, it makes sense because we are catching now, depends on the code. And why I say error code, because this one is just one throw. Perhaps I have later other error codes and I have to react. And what you want to do, and we learned in a try catch block, you have now to react. And that's very important that you figure this out here at this point. At this point, this if here one of this is a null pointer, which means it's not possible to start this whole function here. So this whole function will be not possible. So in my case, what I did, let me see what I did there. And this error code, first of all, I made again a if this, the reason why I made a if, because I have another error code here too. So this is just to make one if error code 77. I said, okay, here just an outprint. I said error, swap pointer first position and swap pointer second position failed. That is exactly that what I check. That's why I said, let's see, not here. That's why I said this one here. This one failed, and that's why we have this catch here. And then I give here a hint. You can make it a little bit more descriptive and better. This is just for demonstration purposes. Probably null PTR, but must be not the case. It can fail anything else. That's why I say probably null PTR, must have a value. And I return here with -1. This number is again random most time. And it indicates, it's not random, sorry, careful. This return is in our main, and main means this here will go back to main, and this main function is finished, which means our program, our whole program is finished. But important is it is finished with the code -1. -1, there are actually, this is just, doesn't matter if it's -1 or so, -1 or anything else means it succeeded, not successful. So return main, not succeeded, successful, because we know when we have in main return 0 means our program was okay, all expected, perfect. Return -1 or anything other than 0 means the whole program, there was an error, it is unexpected, interrupt, it should be shut down or whatever. And this is this indication here. And let me copy this one here as well. And here is something else what you can see, which I included. You could use one of these interrupts, for example, this std exit, there is abort, and many other ones. But careful, you have to read what they really do. If this is good, there are different theories behind that when you use that and when not. Sometimes you have to interrupt immediately, so which means there is something so important that you interrupt it right now when the error occurs, then you can't probably use this returns 1 here. Then you have to go out as fast as possible. And there are sometimes you just say return 1, and there is most time then something like stack unwinding, which means which means all your variables and all your things are freed accordingly to the program. But sometimes you can't wait so long. There are situations where you say stop, just stop, go out, and we will handle all what comes later manually by the programmer. So that's very important, but we will talk about this again when we talk about exceptions again. Or I talked about this in exception, but here is again a use case where you have to think about it. All right, so I copied this code, this error code in my catch block. Let's copy this one. I paste this catch here in. So, and like I said, this is not the best way. You should normally use here this std catch library, but we have not talked about this. This is why I use this one. And of course, remember again with this try catch block, you can make here actually more catches. You can write here another catch. Perhaps you remember this one, and then you say, oh, I don't know, you can write here other things as well. You can add here more catches, a general catch, and there is much thing. But important is that you understand why I did this try catch block, because we are catching potential errors. All right, I think we stop now with 19. There is not so much left because all that what comes now are more catching. We will catch a lot now because there can happen a lot. And in my next video, we catch some more things. All right, with that said, if you have any question or any complaints, like all time, write it in the comments, and see you in the next video. And again, learn a little bit flowcharts, because I will show when we finish with the sort the whole code again in flowchart, and you say, whoa, now I understand the code very easy. Why the hell we have not used this from the first time? And the reason is because you have to learn it first what a flowchart is. And yeah, with that said, see you in the next. Bye, good luck, and have fun. And of course, try it on your own. Very important that you try it on your own, not just following this tutorial. Just code it and see what you can. Don't worry about mistakes. If you make mistakes, it's even very good, because then you try to learn fixing these mistakes, and that is very important for a programmer in the future as well. Bye, good luck, and never give up.